Hello, ladies. We're going to start chapter 8, which is titled Rotational Motion. Now, I'm going to warn you, this is a little bit different than some of the others, but I don't think it's any harder than the other chapters. In some ways, you just have to change your thinking a little bit. As you can see, all the problems are listed there, but you don't have to worry about writing those down. I'm also including a PDF document of all the problems that are typed out in the book. Now, you can use your book, but that will be on the sheet. So if you just want to print those problems off, you can do that, or just have them on the screen and write them on a piece of paper in your notebook or wherever you want to. That's entirely up to you. I will also include a formula sheet just in case you don't have yours. What I'm going to ask you to do with your problems is once you have attempted all those through the first set of assignments that we get to, is to just take a picture of those and upload them into Google Classroom as proof to me that you've attempted them. And then what I will do is give you credit for those problems. That will be more of the grade this section than normal. I do not plan on giving a test over this, but I will also post the problems with correct solutions at the end. Feel free to message me if you have questions. You can probably also use an app called Zoom. It's a free download that you three could get together and online discuss the problems. After each page, I will also be giving a little bit of pause if there's anything you need to write down, but with having a PDF of all the notes, that should not be an issue for you. Rotational motion, often referred to as pure rotational motion, is when all points in an object move in circles and the centers of these circles all lie on a line called the axis of rotation. That means that all of our things that we've been talking about, like velocity and acceleration, have to be a little bit different. And this is where the different thinking comes in. You notice I have there not velocity, but angular velocity, because it's velocity around a circle, and everything in the circle can be thought of as an angle. We use a different symbol for angular velocity. It looks like a curly Q fancy W, but that is the Greek letter omega. And I always remember omega's angular velocity because W and V are close to each other in the alphabet. What is angular velocity then? The angle through which an object rotates in time t. And you can see from the formula there, omega is equal to theta over t. Now t is time, that doesn't change. Theta is just your angle, but we don't measure the angles in degrees, we do them in radians. Now, don't be thinking, oh, I have to put my calculator in radians now. Nope, it's just another number like meters. It's just the label is radians. So don't be thinking, oh, I've got to get everything in radians. We're not going to be doing it that fancy in this section. Then we also have a new acceleration called angular acceleration, and that uses the Greek letter alpha. And it kind of looks like the A from acceleration, so I never had a hard time remembering that. What is angular acceleration then? The change in angular velocity divided by the change in time. So it is delta omega divided by delta t. So where acceleration was meters per second squared, angular acceleration is radians per second squared, which is kind of similar. Now on tests in the past, I had you memorizing all the labels. We're not going to worry too much about these. Just remember that meters is now radians, seconds stays stadians. You may want to jot that down because that's a little bit of something new and it might help you to remember if you see radians per second. Oh yeah, that's angular velocity now, or radians per second squared is angular acceleration. Two newer things to talk about are under the heading of angular velocity and frequency. Frequency, or lowercase f, is the number of revolutions per second. And if you think about it, one revolution in a circle is 360 degrees or 2 pi radians. We measure frequency in hertz. And so a hertz would be radians per second is how we think of it. So frequency is angular velocity over 2 pi, or omega divided by 2 pi, because there's 2 pi radians in one circle. Period capital T, is the time required for one complete revolution. Period is equal to inverse frequency, or 1 over f, or you can just inverse the formula for frequency and make it 2 pi divided by omega. Now, if that gets a little confusing, just remember they're just opposites of each other. All right, let's talk about the kinematic equations for uniformly accelerated rotational motion. This page might look a little intimidating at first, but don't let it be, because the first column, those linear equations, we've been using them since second quarter, or maybe even the end of first quarter. If you can't remember, look at that third one, v squared equals v initial squared plus 2ad. We've used that a lot. And remember, the initial is just that lowercase 0, meaning the beginning. Each one of those equations can be written for rotational motion. All we're going to do is, if you look at the equivalent symbols, anywhere there's a v, we're going to put in an omega, d we'll put in theta, and a we will put in alpha. So the v equals v initial plus at will now be thought of as omega equals omega initial plus alpha t. And each one of those equation changes are on your formula sheet. But it's kind of nice to see a correlation between them of which ones they relate to. Often in that second equation, just like in the first one there with d equals d initial plus v initial t plus 1/2 at squared, d initial is 0. So there is no initial distance. There will be no initial theta as well. Often that is 0. At this time, I've gone through most of the stuff that you need to know to start solving problems, and I'd like you to work on the first 5 of them. Now, since I'm getting this a little late to you in the week, let's try and have these done by Monday. That gives you 5 days to work on them, and I'm not going to worry about having a grade posted for you guys until then. If you get them done and you want to turn them in early, that's great, but don't worry about that. Feel free to email me if you have problems. We can set up time to use something called Google Hangouts to talk back and forth, and I could even use the Zoom if you wished. I do not have a whiteboard at home, but I could write on a piece of paper with a marker to help you see. Good luck, ladies, and hopefully you are not going stir crazy yet.